Hi champs, welcome back, and in this video we will continue our discussion on the various types of reactions that we discussed, and what we will be discussing here is displacement reaction. Now there are many interesting concepts in displacement reaction. Okay, now before we go ahead, let us see some examples here. Now the first example is when you put some iron in copper sulfate solution. When you put iron in copper sulfate solution, the iron reacts with copper sulfate, it forms iron sulfate and copper is released. And that reaction will be like this. Fe plus CuSO4, it gives FeSO4 and Cu in solid. So hope you see that. Okay. Now there are two other examples. Zinc with copper sulfate gives zinc sulfate and copper, and then lead with copper chloride gives lead chloride and copper. Very good. So we have all these examples. Now there's something, there's something about copper here. This poor boy copper, he has stable compounds like copper sulfate, copper chloride, but he always gets displaced. Copper gets displaced. Why? You will have that question. You should actually have that question. So why does this happen? Right? So to understand why this happens, we need to understand the concept of reactivity. So reactivity is the measure of how fast, easily or readily an element can undergo chemical reaction. That's what is reactivity all about. So let's try to understand reactivity. Let's see what really makes some elements more reactive. Now, one example we see here is sodium. See, sodium is a very highly reactive element. All you need to do is expose sodium to atmosphere, it will burn violently. It'll give a small burst also, it will burst into small pieces, it will burn in the air. You need not do anything. It will simply react with the oxygen in the air, it will form sodium oxide. And that reaction is very violent, it burns. So, how do you store sodium? Sodium is stored under kerosene so that such reactions don't take place. So when you want to use sodium for any reaction, you need to take it from the kerosene, cut it, use it immediately before the kerosene evaporates. So you need to use sodium like this. So these are highly reactive. So there are elements that are not highly reactive, but still if you add acid to them, they react. And then there are some elements which don't react at all, or which are very slow to react. Right? So let's see what are those and why are those like that. So if an element is very reactive, then it can burn either in air or in water. That is one example of sodium. And in the above examples, we can conclude that zinc, iron are more reactive than copper. In fact, lead is also more reactive than copper. So zinc and iron can replace copper from a compound like copper sulfate. Right. Now, if you add copper to an aqueous solution of an iron compound or a zinc compound, what will be the reaction? You guessed it right. There will be no reaction because copper is not more reactive than iron or zinc. So the copper filling that you put inside the aqueous solution will remain as copper filling only. No reaction will ever happen. Right? So it is only the higher reactivity element. The element with a higher reactivity will replace the element with a lower reactivity from its compound. Vice versa cannot happen. The reverse cannot happen. Okay. So if an element is highly electropositive or highly electronegative, those elements tend to be more reactive. Now what is electropositivity? Electropositivity is the ability of an element to lose 1, 2 or 3 electrons. When the electrons are lost, the number of protons becomes higher and it gains a positive charge. So metals usually are electropositive. And what is electronegativity? The ability of an element to attract electrons to itself and hold the electrons in a covalent bond. Now that is what is electronegativity is all about. And non-metals are usually electronegative. When you find any element that is high in electropositivity or high in electronegativity, those elements are highly reactive. Right? So electropositivity can be defined as the tendency of an atom to lose or donate the electrons to form positively charged cations. Cations are positively charged, anions are negatively charged. Okay. When it comes to electrodes with electric charge, cathode is negatively charged, anode is positively charged. So the positively charged cations go to cathode, which is negatively charged. Positive getting attracted to the negative electrode, and the negative ions are anions, and the negative anions go towards the positive electrode called the anode. Right? Now this is about electrolysis. This is what happens in electrolysis. So the metals in particular, the alkaline earth metals have the tendency to donate an electron to form cations that are positively charged. Electropositivity is generally exhibited by metals, and the atom or molecule that loses electron carries a positive electrical charge. This is called an electropositive radical. So what is an electropositive radical? A radical in chemistry is an atom, molecule or ion that contains an unpaired valence electron. So what is the measure of electronegativity? Electronegativity is the power of an atom in a molecule to attract electrons to itself and hold those in covalent bonds. So here let's look into, let us look at some of the examples of, highly reactive metals and non-metals. See, in metals, francium is regarded to be very highly reactive, but we don't find francium in a stable isotope form. It is radioactive, but for all practical purpose, we can consider cesium as a highly reactive metal. When it comes to non-metals, fluorine is regarded to be highly reactive. Okay, so let's see, aluminium can lose 3 electrons very easily. So the valency of aluminium is 3, and it forms an aluminium cation. It can lose 3 electrons and it gains 3 positive charges, plus 3. And ferrous ion has 2 positive charges and ferric has 3 positive charges. It simply means that the valency of ferrous ion is 2 and the valency of ferric ion is 3, and they have the tendency to lose 2 and 3 electrons respectively. Okay, so cesium is a stable isotope known to be the most reactive metal. Okay, now let's look into the reactivity series. Potassium, sodium, lithium, barium, all these are highly reactive. It can react with water also, and there are other stable elements, magnesium, aluminium, manganese, zinc, chromium, iron. All this is only a partial list. It's not a complete list. It's a partial list that gives you the reactivity series. Now here, what it really means is that potassium is more reactive than sodium. Sodium is more reactive than lithium. Lithium is more reactive than barium. It goes like that. Okay. So the reactive alkaline earth metals like tin, lead, aluminium, magnesium, manganese, all these, they can react with acid. So based on the above table, potassium reacts with calcium chloride. Okay, potassium is high on reactivity, calcium is low on reactivity. When potassium reacts with calcium chloride, it will replace calcium and it will form potassium chloride. There it goes. And then we have antimony, bismuth, copper, the poor copper, mercury, silver, gold, platinum. Now you understand why copper is replaced by lead, zinc and iron, because they are more reactive. See, copper is highly unreactive. Copper doesn't react very easily, so it's highly unreactive. That's the reason it gets easily replaced by the elements that are more reactive than copper. So there we go. So this is only a partial list, okay? It's not the complete list. And you can do some research, and if you're really interested, then you can go ahead, look at the complete list of the reactivity series. Okay. And with non-metals, we have fluorine, chlorine, bromine is as reactive as oxygen, and iodine, sulfur. This again is a partial list. So the reactivity of metals depends on their capacity to lose electron, and the reactivity of non-metals depend on their capacity to gain electrons and hold the electrons. It can be an ionic bond or it can also be a covalent bond. The capacity to hold the electrons. That's what is the reactivity of the non-metals all about. So, thank you. Let's meet in the next video.